So for section 3.1, solving right triangles, our objective is to solve right triangles using the 6 trigonometric functions. Hey YouTubers, welcome to your first episode of math with me and Anna. And today we're going to be learning how to solve right triangles. And so first basic thing about learning how to solve right triangles is you have your SO, you have your COT, and you have your TOA. And these things, this basically stands for sine, this means cosine, and this is your tangent. So when you're trying to find a angle measure or a side length, you use these so-called formulas to help you. So you take this one, you take the angle, so you have sine A, which is angle A, and you take the opposite, the side opposite to it, which is A, and then you take the hypotenuse, which is C. So you have A over C, and that's your answer. And if you're trying to find cos B, you would take the side adjacent away from angle B, which is this one, it's A, and then you take the hypotenuse, which is C. So you have the same answer again, A over C. And then to find tangent A, tangent you take the angle A, and you take the side opposite of it, it's opposite again, and then you take the side adjacent over it, which is B. So it's A over B. So for our first problem, we have to solve the right triangle here, and we are given angle A, which is 15.1 degrees, and side B, which is 10.7 units. So to find angle B, it's real easy. You just take 90 from here, and you take the 15.1, and you just add it. And then you subtract that from 180. And you get 74.9 for angle B. And then from that in. Now we're going to solve for side A, and we're going to get our SOHCAHTOA out. And we're looking for the angle opposite of it. Take the tangent, because it uses the opposite in the adjacent side. So you take tangent of 15.1 degrees equals A over 10.7. And then you multiply by 10.7 on both sides, and this cancels out, and you find tangent of 15.1, which is 0.2698, and you multiply it by 10.7, which is 2.89. So A equals 2.89. And now to find side C, you can do two things. You can take these two and you can use Pythagorean theorem because it is a right triangle, or you can find it using one of these methods, but I'm going to use the Pythagorean theorem because it's easier. So you take 10.7 and you square it, and you add it to 2.9, which is also squared, and that comes out to about 122.9. And then you take the square root of this, and you get about 11.1, and that is your side C. So as you can see, we have solved the triangle because we have found all of the missing numbers. Problem number 2, we're also going to solve the triangle again, but this time we are given angle B, which is 25 degrees, and side A, which is 32. So first things first, we gotta find angle A. So we take 90 and we add 25, and you get 115. And then you take 180 and subtract it from 115, which is 65 degrees. So we know that. So angle A equals 65 degrees. Okay, and then we're gonna take angle A and we're gonna find side B by using tangent. So we're gonna use opposite over adjacent. So we take tan 65 equals 32 over B. And then we're going to multiply by B on both sides, which you can get B times tan 65 equals 32. So to get B by itself, you have to divide by tan 65. So you take tan 65 and divide it on both sides. When you take your 32 over tan 65, you get about 15 when you round up. So B equals 15. And then, now once you have your two sides, you can just use Pythagorean theorem, which is 15 squared plus 32 squared equals c squared. And you get 225 plus 1024 equals c squared, which is 1249 equals c squared, and you square root both sides, and you get c equaling about 35. And that is your solved triangle. So for your first practice problem, you have a apartment building which is 63 feet tall, and you have a ladder leaning against the building, creating a 47-degree angle of elevation. And your goal is to find the length of the ladder. Pause. Answer 86, because if so, good job. So I'm basically going to show you how we got this answer here to find the length of the ladder. So I took the sine of 47, this angle here, so we did opposite over hypotenuse. So I took 63, the opposite, and I did it over the hypotenuse, which is h. And then I multiplied it by h to get that out of there. And then you do it on both sides. So when you do this, you end up with this, and you have to divide by sine 47, and you divide 63 by sine 47 also, and you get about 86 feet, and that's how tall the ladder is. For 5-3 tangent sum and difference identities, our objective is to develop and use formulas for the tangent of a sum or difference of two angle measures. For these, we have two different formulas here. If you're going to add the two angles together to receive your sum of whatever, you take the formula tangent of your first angle, which is called alpha, and then you add it to the tangent of your second angle, which is called beta. And then it's all over 1 minus, it's different here. And then you take the product of tangent A and tangent B. And for the difference, it's very similar. You just take tangent A, except you subtract it here. And then on the bottom, you add it. It's still the opposite. And you take the product of tangent A and tangent B. When you're dealing with these tangent problems, you're going to want to pick two angles that are what we call good angles here, whether they have a 45 in them or a 60. So you take, to find this, you take, see this would be 135 degrees here. So you subtract 135 from 90 and you get 45. So that's how you know it works. For this, it's just in the first quadrant. Say if it were to be over here, you would take 60, this would be 30, this would be 90, and you would take 240 and subtract it from 180 to get 60, which is that. First one, we have tan 105 degrees. So two angles that add up to this are 60 here, and that's root 3, 1 and 2, and then the other angle is 45. So we take our 45-degree angle, and we 1, 1, and root 2. Okay, So for this, you basically just plug it in here. So the tangent of alpha would be y over x, or root 3 over 1, which is root 3. And then you add it, and to the tangent of b, which is 1 over 1, which is 1. And then you do 1 minus, and then you just plug these in, and you have root 3 plus 1 over 1 minus root 3. And then you're gonna have to multiply it by the conjugate on the bottom because the denominator is not rationalized. So you're going to take 1 plus root 3 and multiply it in the denominator and the numerator. So for the bottom, you don't have to do the whole thing because, as we know, this is one of those. So you take 1 and minus 3 because 1 times 1 is negative root 3 times root 3 is negative 3. But on the top, you have to FOIL it out. So you take the first one, it's root 3, and then times the last one is 3, and then you take 1 times 1 is 1, and 1 times root 3 is root 3. So you end up with 4 plus 2 root 3 all over negative 2. We're going to come over here, and your final answer is going to be negative 2 minus root 3. So your first problem, you're going to have to find the tangent of alpha minus beta. And we gave you the cosine of alpha, which is 3 over 5, and we gave you the sine of beta, which is negative 5 over 13. And we also told you that alpha is in between 270 degrees and 360 degrees, and beta is between 180 degrees and 270 degrees. This problem, we took the cosine of alpha and the sine of beta, and we put them in on a x-axis and y-axis. So we took this information and we found out that alpha was in the 4th quadrant, and we knew these because of the special right triangle of 3, 4, 5. And for this one was beta, we did the same thing except it was 5, 12, 13. So we just plugged in the tangent of alpha, which we got by going 5 over 12, and we added it to, or it was negative 4 over 3, so it's minus, and then you do it over 1 minus 5, 12, 4 over 3 is the same thing. And then here, you find the product of this, which is 20 over 36, and then you multiply it by 36, which cancels these out, and you get 36 minus 20 on the bottom. And then for this, you can take 36 and divide it by 12, which you get 3, and you multiply it by 5, and you get 15, and you get 36 divided by 3, which is 12, and then you multiply it by 4, which is 48. And then for your final answer, you get 63 over 16. That's it.